This video will cover some introductory information on Amazon S3, or Amazon Simple Storage Service. S3 is storage for the internet. It's designed to make web-scale computing easier for developers. Amazon S3 has a simple web services interface that you can use to store and retrieve any amount of data at any time from anywhere on the web. It gives any developer access to the same highly scalable, reliable, fast, inexpensive data storage infrastructure that Amazon uses to run its own global network of websites. One of the greatest advantages to S3 is that it's intentionally built with a minimal feature set that focuses on simplicity and robustness. It'll allow you to create and name a storage bucket that stores data. Buckets are the fundamental container in Amazon S3 for data storage. It'll also allow you to store an infinite amount of data in a bucket. You're allowed to upload as many objects as you like into an Amazon S3 bucket. Each object can contain up to 5 terabytes of data. Each object is stored and retrieved using a unique developer-assigned key. You're also able to control your permissions for S3 by granting or denying access to others who want to upload or download data into your Amazon S3 bucket. You're able to grant upload and download permissions to 3 types of users. Authentication mechanisms can help keep data secure from unauthorized access. It's also designed to be very easy to use because S3 uses standards-based REST and SOAP interfaces designed to work with any internet development toolkit. Now that we've talked about a little bit about what S3 is and some of the advantages it offers, let's talk about some of the key concepts for S3, and the first and most fundamental is the bucket. A bucket is a container for objects stored in S3. Every object is contained in a bucket. Buckets serve several purposes. They organize the Amazon S3 namespace at the highest level. They identify the account responsible for storage and data transfer charges, and they play a role in access control. And finally, they serve as the unit of aggregation for usage reporting. Next are objects, which are the entities stored in Amazon S3 buckets. Objects consist of object data and metadata. The data portion is opaque to S3. The metadata is a set of name-value pairs that describe the object. These include some default metadata, such as the date last modified, and standard HTTP metadata, such as content type. You can also specify custom metadata at the time the object is stored. An object is uniquely identified within a bucket by a key and a version ID. And when we start to dig into S3 on the console, you'll get a much better idea of what I'm talking about. Next is a key, which is the unique identifier for an object within a bucket. Every object in a bucket has exactly one key. Because the combination of a bucket, key, and version ID uniquely identify each object, S3 can be thought of as a basic data map between bucket and key and version and the object itself. Every object in S3 can be uniquely addressed through the combination of the web service endpoint, bucket name, key, and optionally a version. And finally, you can choose the geographical region where S3 will store the buckets you create. You might choose a region to optimize latency, minimize costs, or address regulatory requirements. Objects stored in a region never leave the region unless you explicitly transfer them to another region. And now that we've covered some of the key components of S3, let's talk about S3's data consistency model, and that includes read after write consistency and eventual consistency. S3 provides read after write consistency for puts of new objects in your S3 bucket in all regions with one exception. The exception is that if you make a head or get request to the key name before creating the object, S3 provides eventual consistency for read after write. For overwrite puts and deletes in all regions, S3 offers eventual consistency. So, to quickly reiterate here, for puts of brand new objects in a bucket, S3 will provide read after write consistency. But for overwrite puts or deletes of objects in any region, S3 will provide eventual consistency. S3 achieves high availability by replicating data across multiple servers within Amazon's data centers. If a put request is successful, your data is safely stored. However, information about the changes must replicate across Amazon S3, which can take some time, and so you might observe some of the following behaviors. One behavior is if a process replaces an existing object and then immediately attempts to read it. Until the change is fully propagated, S3 might return the prior data. Another scenario is if a process deletes an existing object and then immediately attempts to read it. Until the deletion is fully propagated with eventual consistency, S3 might once again return that deleted data. And that about covers it for S3 basics and S3 data consistency. So if all of that makes sense, then feel free to move on. In this video, we're going to talk about storage classes for Amazon S3. And the first category of storage class is for frequently accessed objects. In this class, we have two different subclasses. Standard, which is the default storage class, and if you don't specify the storage class when you upload an object, Amazon S3 assigns the standard storage class. And reduced redundancy. The Reduced Redundancy Storage, or RRS storage class, is designed for non-critical, reproducible data that can be stored with less redundancy than the standard storage class. And just as a quick note, while you can choose the Reduced Redundancy option when uploading an object to S3, AWS does not recommend that you use this storage class. The standard storage class is more cost-effective. Next, we have two storage classes for infrequently accessed objects. The Standard IA and One-Zone IA storage classes are designed for long-lived and infrequently accessed data. While both storage classes are available for millisecond access, S3 charges a retrieval fee for these objects, so they are most suitable for infrequently accessed data. You might choose either Standard IA or One-Zone IA for older data that is accessed infrequently but that still requires millisecond access. For example, when you upload data, you might choose the Standard storage class and then use lifecycle configuration to tell S3 to transition the objects to the Standard IA or One-Zone IA class. In Standard IA, S3 stores the object data redundantly across multiple geographically separated availability zones, similar to Standard storage class. For that reason, Standard IA objects are resilient to the loss of an availability zone. This storage class offers greater availability, durability, and resiliency than the One-Zone IA class. In contrast to the Standard IA, One-Zone IA stores the object data in only one availability zone, which makes it less expensive than Standard IA. However, the data is not resilient to the physical loss of the availability zone resulting from disasters such as earthquakes and floods. The One-Zone IA storage class is as durable as Standard IA, but it is less available and less resilient. AWS recommends that you use Standard IA for your primary or only copy of data that can't be recreated, and One-Zone IA if you can recreate the data if the availability zone fails, and for object replicas when setting cross-region replication. And finally, there's the Glacier storage class, which is suitable for archiving data where data access is infrequent. Archived objects are not available for real-time access. You first have to restore the objects before you can access them. Note that you can't specify Glacier as the storage class at the time that you create an object. You create Glacier objects by first uploading objects using Standard, RRS, Standard IA, or One-Zone IA as the storage class. Then you transition these objects to the Glacier storage class using lifecycle management, which we'll go over more in a future video. And that'll wrap it up for this quick introduction to S3 storage classes, so if all of that makes sense, then feel free to move on. In this video, we're going to talk about managing access permissions to our Amazon S3 resources. By default, all S3 resources, including buckets, objects, and related sub-resources like lifecycle configuration and website configuration, are private. Only the resource owner An AWS account that created it can access the resource. The resource owner can optionally grant permissions to others by writing an access policy. S3 offers access policy options broadly categorized as resource-based policies and user policies. Access policies you attach to your resources, including buckets and objects, are referred to as resource-based policies. For example, the bucket policies that we're going to cover in this video and the access control lists that we're going to cover are resource-based policies. You can also attach access policies to users in your account. These are called user policies, and we'll cover them in another video. You may choose to use resource-based policies, user policies, or some combination of these to manage permissions to your S3 resources. The first method we're going to cover are access control lists, or ACLs. Access control lists are one of the resource-based access policy options that you can use to manage access to your buckets and objects. You can use ACLs to grant basic read-write permissions to other AWS accounts. There are limits to managing permissions using ACLs though. For example, you can grant permissions only to other AWS accounts. You can't grant permissions to users in your account. You also can't grant conditional permissions, nor can you explicitly deny permissions. ACLs are suitable for specific scenarios then. For example, if a bucket owner allows other AWS accounts to upload objects, permissions to these objects can only be managed using Object ACL by the AWS account that owns the object. What we're looking at is the ACL for the bucket mat example bucket, and you'll notice we have a few different categories of permissions. We have access for our AWS account, and if we click on it, we'll notice that we can control both the objects and access to the bucket's ACL using list and write for the objects and read and write bucket permissions for the ACL. We also have the ability to add other AWS accounts, and we can do that by simply entering an account ID or email address and then determining the permissions that we want to attach to that account. While this next option is only recommended in specific scenarios, such as serving static content or website content, you can also configure access for everyone and give public access with a variety of categories. And then finally, you can categorize your S3 log delivery group using the same permissions. You also have the option to configure permissions to your S3 bucket using a bucket policy. Now, we're definitely going to cover bucket policies in more detail in a future video, but for now, just know that there are a few common elements in an access policy. The first are resources, or what you're allowing access to. For a bucket policy, buckets and objects are the Amazon S3 resources for which you can allow or deny permissions. In a policy, you use the Amazon resource name, or ARN, to identify the resource. Next are the actions, or the API calls that you're allowing to be made against your resource. For each resource, Amazon S3 supports a set of operations. You identify resource operations that you will allow or deny by using action keywords. Next is the effect, which you can set to either allow or deny. You should note, though, that if you don't explicitly grant access to allow a resource, access is implicitly denied. You can also explicitly deny access to a resource, which you might do in order to make sure that a user can't access it, even if a different policy grants access. And finally, there's the principal, or the account or user who is allowed to access the actions and resources in the statement. In an S3 bucket policy, the principal is the user, account, service, or other entity who is the recipient of this permission. So let's take a minute to summarize what we just went through and see what it means in this bucket policy. This policy is allowing a principal with the account ID of some account ID and the user named Dave to perform these three actions on these resources. In other words, Dave from this account is going to be able to get objects, get bucket locations, or list the bucket for the example bucket or any item inside the example bucket. And that'll wrap it up for our summary of S3 permissions management using ACLs and bucket policies. So if all of that makes sense, then feel free to move on. So far in this course, we've covered the basics of cloud computing in AWS, including computing in EC2, Lambda, and Beanstalk. If you recall, EC2 were AWS's virtual machines that are highly configurable. Lambda is compute power that's completely managed so that you don't have to mess with the operating system or the underlying instances. And Elastic Beanstalk was a very easy way to get applications up into the cloud very quickly. We also covered S3, EFS, and Glacier. We pointed out that S3 was very easy to use and intuitive object storage. Elastic File System was highly scalable and shareable storage for EC2 instances and other occasions, and Glacier was very affordable, infrequent access storage. We also very quickly covered the difference between regions and availability zones, and we pointed out that regions were different physically isolated places that AWS offers you to deploy resources into, and that each region had multiple availability zones inside it. Another thing we covered was the shared responsibility model. And we talked a little bit about which parts of your security are your responsibility and which parts are AWS's responsibility. And finally, we touched on AWS service limits and how to get around them by completing a service request. For EC2 instances, we learned what an EC2 instance is, which is the fundamental virtual machine that AWS offers for compute in the cloud. We learned that from the EC2 dashboard, you can view running instances, and then for each instance, you can view all sorts of information, including any public DNS information it has, the VPCs and subnets that it's attached to, any security groups that it belongs to, and IAM roles that it belongs to. We also learned that if we launch an instance, we get to decide the AMI, or Amazon Machine Image, that we use for it. We also get to decide which instance type we use for it, which pertains to the amount of CPU and memory it has, how to deploy it into different subnets, or VPCs, and then how to assign different IAM roles to it, what EBS is, and how to both change the amount of storage that's stored on EBS, as well as attach multiple EBS volumes to it, how to configure security groups, and then finally, how to use key pairs to access the server once we've deployed it. We learned that security groups control ingoing and outgoing access for servers. And we also learned how to use launch configurations and auto-scaling groups in combination with load balancers and target groups to automatically scale in and out for our EC2 instances. For S3, we learned what S3 is, which is Amazon's fundamental, very intuitive bucket and object-based storage service. We learned that storing something is as simple as having a bucket and a key, which is the location inside the bucket of any object. We learned that when we upload a new object, we can choose storage classes, encryption, and we can also add metadata and tags. For buckets, we learned that if we create a bucket, we can enter specific unique DNS compliant names and choose a region that we deploy the bucket into. We also learned that we can enable versioning and server access logging for the bucket, as well as encryption using a couple of different methods. We learned that while creating a bucket, we can also edit permissions for different owners and users for that bucket. Also, for any particular bucket, we learned that we can change its properties, including versioning, server access logging, default encryption, and several others. And finally, we learned that we can change the bucket policy to allow different people to perform different actions on the bucket, and then we can also edit our cross-origin resource sharing using CORS configuration for the bucket.